5-1 Day 2 Angles and Radian Measure. So in the previous lesson, we learned how to convert degrees to radians. So I want to do a quick refresher before we started this lesson. And if you remember, to convert the degrees to radians, you take your degree and you multiply it by pi radians over 180. So this is the conversion factor we're going to use to change the degrees to radians. So I want you to try these 3 examples. So stop the video so you can see if you get it right. So in each case, I multiply the degree by pi over 180 and I reduce the fraction. You don't have to write pi radians. If you got them all right, then you're ready to move on. If not, please make a note and we'll answer your questions the next day. Now let's convert radians to degrees. So our conversion factor will be a little bit different. So you'll take your radians, or your pi radians, and you'll multiply it by 180 over pi radians. Because your whole point is for the units to cancel so you can convert radians to degrees. So if we had pi over 3, and we wanted to convert it to degrees, you would multiply by 180 degrees over pi. And you don't have to write the word radians if they don't write it. So you'll get 180 or 180 degrees divided by 3, which comes out to be 60 degrees. Now, if they have 1 radian and you wanted to convert it to degrees, your conversion factor will also need the unit radians, because you want like units to cancel. So you are still left with pi. Usually they're going to tell you to round this, so you would do 180 divided by pi, and you are left with, or you should get approximately 57.3 degrees. So when you're drawing angles in standard position, there are some things that you need to know. If the angle you are drawing is positive, you're going to rotate counterclockwise, and you always start with the positive x-axis. If the angle you are drawing is negative, you're going to rotate, starting here, again, positive x-axis, you'll rotate clockwise. And I'll just go over what we call quadrant angles, because remember our quadrants are 1, 2, 3, 4. So the angles are 0 degrees, 90, because they're all right angles, 180, and 270. If you go back around, you're back at 360. So just so you know that. And then you can also convert those to radians. So in radians, if you change degrees of radians, 0 degrees, pi over 2, 1 pi, 3 pi over 2, and 2 pi. So let's say they wanted us to draw pi over 4 in standard position. So a full circle is 2 pi units. I have to find out what fraction of this circle represents pi over 4. I don't know, so if you don't know, this is a formula that will help you. What fraction, I'm going to call it x, of 2 pi is equal to pi over 4? So I'm going to divide by 2 pi. If you don't like dividing fractions, you can change this. So you multiply by the reciprocal. and that will give you 1/8. This number tells you how to divide your circle. So I'm going to divide it into 8ths. And when you draw your angle, you always want to start with your initial side. And if it's positive, you're going to count counterclockwise. And I'm only going to go 1/8. So just one section. And extend your terminal side so you can show your rotation. Okay, let's try another one. What if it was 7 pi over 6? Use the same concept. What fraction of 2 pi is equal to 7 pi over 6? You divide by 2 pi, or you can multiply by the reciprocal, which gives us 7 over 12. This number tells you how to divide your circle. Now remember, it's better to either use 8ths or 12ths if you can, because it makes it easier. So remember the circle I started off with? Now I'm going to divide it into 12ths. Alright, so you draw your initial side and you count 7 12ths. 1, 2, 3, 4, 5, 6, 7. Show your rotation, show your terminal side. And what if the angle is negative? Still the same thing. What fraction of 2 pi is equal to negative 2 pi over 3? I divide by 2 pi because I don't know the answer. Remember, that's the same thing as multiplying by 1 over 2 pi. Soon you're not going to have to show this step because you know you're going to go directly to this. So my pi's cancel and I'm left with negative 2 over 6. Well, we can't really divide our circle into 6 even parts. So what I'm going to do is convert this to 12ths. This is the same as negative 4 over 12. So I'm going to draw my circle again, dividing it into 12ths. Be careful now, it's negative. So we have to rotate clockwise. 1, 2, 3, 4. Show your rotation, show your terminal side. And there's negative 2 pi over 3. So now we're going to look at coterminal angles, and these angles have to be less than 360 or 2 pi. Degrees, 360, 2 pi radians. Coterminal angles are two angles with the same initial side and same terminal side, but possibly different rotations. So for example, if we had 420 degrees and they wanted us to find the coterminal angle. Well, one way that helps me, especially if you don't want to draw it, just note that if your angle is larger than 360, you will subtract to find the coterminal angle. So you're subtracting 360 or a multiple of 360. So 360, 720, any of those. If the angle is smaller than 360, you will add 360 or a multiple. When I say multiple, that means that you're doing it multiple times. And of course, if it's radians, you have to use 2 pi. So let's say it's 420. 420 is larger, so you're going to subtract 360. And you'll get 60 degrees. So that means 420 and 60 are coterminal. Let's say the angle was 750. 750 is also larger than 360, so you would subtract 360. And if you notice, you're going to end up with 390. 390 is larger than 360, so you have to do it again. And so 750 and 30 are coterminal. For those that are visual, this is how it would look if I had to draw 420. 420 would land me here in quadrant 1. And if I just drew 60 degrees, it'll also land in quadrant 1 at the same place. That's coterminal. Okay, so for C, this is smaller than 360, so you're going to add 360 or a multiple. That means you may have to do it a couple of times because you want it to be positive, but you want it to be less than 360. So this comes out to be 240 degrees, which is okay. So 240, which looks like this, and negative 120 are coterminal. D, this is negative again, so we have to add. And as soon as you see radians, you use 2 pi instead of 360. And put it over 1 to help you with the fractions. So we're going to add 2 pi over 1. We have to have a common denominator. So I'm going to multiply the top and bottom by 6. So I have negative 17 pi over 6 plus 12 pi over 6. You're going to notice is negative 5 pi over 6. Well, this is negative, and that means that we may have to do it again. So I'm going to add 12 pi over 6 again, because that's 2 pi. So sometimes you have to do it more than once. And that will give you 7 pi over 6. Well, 6 divides into 7. That's less than 2 times. So that's when you know that you have added or subtracted enough. 22 pi over 3. This is positive, so we're going to have to subtract 2 pi. We already know that 2 pi is over 1. You need a common denominator. So you have 22 pi over 3 minus 6 pi over 3 gives us 16 pi over 3. Well, 3 divides into 16 5 times. That's too big, so you have to subtract again. I'm going to use 6 pi over 3. That gives us 10 pi over 3. 3 divides into 10 more than 2 times. So you have to subtract again. So that gives us 4 pi over 3. Now we got something that's less than 2. 3 divides into 4 less than 2. So that's your coterminal angle.